Okay, so I'm going to show you guys how to solve trig equations, and these are the general steps. I labeled the first two steps as 1A and 1B because you might, depending on the problem, you might do one first over the other, okay? So you might do these steps a little out of order. 1A says to get the equation down to one type of trig function. Okay, usually you want to get down to basics of sine or cosine only, all right? And the ways you can do that are to use all these varieties of equations. Reciprocal equations, for example, cosecant, you would substitute 1 over sine theta, okay, secant 1 over cosine theta, right? You can use double angle formulas. Use a list here. We might hit on one of these in the problem. Pythagorean identities, all right. So substitutions you can make to get it down to one kind of trig function. The second, well, not really, the step 1B would be to rewrite the equation and use algebra skills to set the equation equal to 0. Okay. Sometimes that means to add or subtract the fractions. There could be factoring problems. Okay. So we'll see those in a bit. But definitely the last step is once you set the equation equal to 0, you can solve for the angle. And hopefully you can use a unit circle quickly. If not, I'll show you how to use that as well. Okay, so let's do a problem right now. Secant squared x minus secant x equals 2. I know one of the steps said to get this down to the basics, which would be cosine only, but that would make things harder actually. So let's go ahead and just keep secant for now and just do step 1b, which is to set it equal to 0. You'll see why it's easier. Okay, hopefully you can see how this is a factoring pattern. If not, you can let u equal secant x, and hopefully you see this is a u squared minus u minus 2 factoring pattern. Okay, however, I'm not going to do it like that. I'm just going to go ahead and just factor it as it is. So let me show you how that looks like. I'm going to do my special butterfly method. It'll look nice and pretty. I guess on this side, the two factors are going to be -2 and +1. So when I make my butterfly wings, okay, it's not that pretty, but cross multiply and add them together, you would get negative secant x, which is what we want in the middle. And so those are my factors. It would be top times bottom row. Okay. And now you can go ahead and just like an algebra equation. By the way, we're in step 2 now. We set equal to 0, and now we're solving for x. So I'm going to split this up. Solve for x the rest of the way. Okay, now we're going back to step 1a, which is to get it down to cosine only. So we're going to make that substitution now. And if you want to get cosine x by itself, all it means you flip the top and the bottom. The reciprocal of -1 is still going to be -1. Okay, we'll come back to this in a bit. And on this side, it's going to be 1 over cosine x equals 2. Again, you can see that's 2 over 1. So if you want to get cosine x by itself, it means you take the reciprocal on both sides to get 1/2. Okay, now the rest is just knowing how to use a unit circle. Okay, and if you're solving for x for cosine, that means you're looking for the angle for cosine that gives you a value of -1. So let's take a look at the unit circle. Okay, and a quick review on unit circle. Quick way to use it is depending on the angle for cosine, you're just going to look at the coordinate point and only for that x value. Okay, so for example, we wanted the angle for cosine that gives us -1. So we want coordinate where the x is -1. In that case, the only angle that gives us that is pi. And that coordinate point on the unit circle is -1, 0, x is -1. So we know we want that angle pi. X equals pi. And on the other hand, okay, cosine x is 1/2 means we want the angle for cosine to give these values a 1/2. Okay, so remember this is the x coordinate on the unit circle. So let's take a look. So it looks like those angles are going to be pi over 3, where x is 1/2, and 5 pi over 3, where x is also equal to 1/2. So 2 answers for this one, 2 more answers. So it's going to be, you're going to have a total of 3 answers here. Right in order: pi over 3, pi, and 5 pi over 3. Okay, so that's, let's go to another one. Okay, now this one right here, okay, this is not cosine squared x, this is cosine 2x. This is a double angle setup. Okay, so right now as it is, you can't do anything until we substitute cosine 2x. We don't want that double angle formula or double angle setup. So let's get rid of it by substituting something else. Let me double angle. Here it is. Okay, so we have 3 to choose from. All right, but the one we want will be this one, because we can make the substitution and get an equation with just cosine only. Okay, so let's go ahead and do that. So I'm going to substitute 2 cosine squared x minus 1 minus cosine x equals 0. Okay. This works out nicely. You can tell now it's already equal to 0. Then you can just go ahead and factor it by GCF. Oh, wait a second. I'm just kidding. No, I am not. I'm going to rewrite this so it looks more recognizable. Okay, now I'm going to, this is a factoring problem now. Okay. You can see it's like that. If you let u equal cosine x, okay, so you can tell this is a factoring pattern. So in that case, I'm just going to use my butterfly method again. Left side, the 2 factors have to be this. On the right side, I want to make this guess. I'm going to say -1's down here, +1's up here. Okay. So then, yes, if I make my butterfly wings, my cross multiplication, whoops, I will get negative cosine x in the middle. Cross multiply and add. Okay, so my factors are going to be 2 cosine x plus 1 times cosine x minus 1 equals 0. Split this up. Okay, so unit circle time again. Okay, cosine x equals -1/2. Okay, so what angles for cosine will give me -1/2 this time, not +1/2, -1/2. Okay, so let's look at the x values. So there's going to be this angle, 4 pi over 3. And second quadrant as well, 2 pi over 3. Okay, and the other one I think was -1. Okay, so that's also going to be pi as well. So, oh, never mind, they wanted +1. Okay, so the answers are going to be 2 pi over 3, 4 pi over 3, and 0. The solution here. Okay, so kind of a quick way to do it. There's a lot of skills involved for these kind of problems. So, and so many different kinds of problems with different equations. So it takes a lot of practice to get confident, to get faster. Okay, so keep practicing.